We use tables of equivalent ratios to solve problems. Let's look at a couple of problems here. A jet traveled a distance of 1,200 miles in 8 hours. What rate of speed did the jet travel? Okay, how fast was it going? So the first thing we're going to do is write this as a ratio. And this ratio is a rate because we're comparing miles to hours. They have two different units of measurement. To make this a unit rate, I'm going to divide, I'm going to write a rate with a denominator of 1. 8 divided by 8 is 1. 1,200 divided by 8 is 150. Okay. Now I'm going to make a table of a ratio table to check my answer. I've got 150 in 1 hour, 300 in 2 hours. Okay. Remember, when you're writing ratios, there's a multiplication relationship. 1 times 4 is 4. 150 times 4 is 600. So I can keep going with my table. 900 miles in 6 hours. 1,050 in 7 hours. Okay, and 1,200 miles in 8 hours. Okay, so I wrote a unit rate and I checked my answer with a ratio table, but I can also use it to solve another problem. How far would the plane have traveled in 10 hours? I can just keep my table going. Okay, it'd be 1,350 miles in 9 hours, and in 10 hours, 1,500 miles. Okay, and remember we have that multiplicative relationship, so 1 times 10 is 10, 150 times 10 is 1,500. So that's one way to use tables of equivalent ratios to solve problems. Let's look at another. Jimmy buys 10 pens for every 2 pencils. Rachel buys 12 pens for every 3 pencils. Are there ratios of pens to pencils bought equivalent? Okay, so let's make a table. Jimmy here is going to do 10 pens for every 2 pencils. Okay, so I can just I can fill out my table. 40 pens, he would have 8. Let's check and make sure we have that multiplication relationship. 2 times 4 is 8, 10 times 4 is 40. Okay. Okay, so again, I'm going to just check my relationship here. 2 times 7 is 14. 10 times 7 is 70. Let's go down and take a look at Rachel for a minute. Okay, she buys 12 pens for every 3 pencils. So that would be 24 pens for 6 pencils. 36 pens for 9 pencils. 48 pens for 12 pencils. 60 pens for 15 pencils, and it's always a good idea to check to make sure your relationship's holding here. So 3 times 5 is 15, 12 times 5 is 60. Okay, 72 pens, 18 pencils, 84 pens, 21 pencils. Now how are we going to use the table to see if their ratios are equal? So I have ratio tables here for Jimmy and Rachel, and I don't see any equivalent ratios. I'm going to go through here, and I'm going to take a look through my tables here and see what I can find. Okay, so up here I'm looking at Jimmy's pens, 10, 20, 30, 40, 50, 60. And down here I also found 60 in Rachel's table. Okay, when Jimmy buys 60 pens, he buys 12 pencils. When Rachel buys 60 pens, so Jimmy was 60 to 12. When Rachel buys 60 pens, she buys 15 pencils. Okay, and 60 to 12 is not equivalent to 60 to 15, so I know their ratios are not equal. Okay, ratio tables, tables of equivalent ratios are a great way to solve problems and to make a good visual representation of those problems.